Hey everyone, welcome to GraphQL FM this week. Once again, this week we've got an actual guest. It's not just Tony and I rambling about GraphQL, which should be better. Tony, how are you doing?
Agreed. I'm excited. I'm excited to chat today. As every week, doing well. How about yourself?
I'm doing real good. It's getting dark and it's getting colder here, but this is fine.
Same.
Today we've got Andy Ingram with us. If you don't know Andy, I think like the first blog post I've ever read about GraphQL and the first time I've heard of things like data loaders, it was actually from blog posts from Andy. They're always amazing. Andy has been in the community for like a very long time, 5 or 6 years. We were just chatting before. So Andy, welcome to the show.
Hi, it's great to be here. Thanks for having me on.
Thank you so much for coming on. So I think one of the first thing I wanted to touch on is you're very vocal on Twitter about how Relay is great, Relay client. And Tony was mentioning before the show how I think one of your first blog posts is like, I'm not ready for Relay yet. So
yeah,
I kind of want to hear about like, what are your thoughts behind that? Like,
are you ready yet?
Yeah.
I think there's still room for improvement, but of the clients that are available, it's the closest one that fits my view of how GraphQL should be done. But I think it's more, without going into the full background, the more interesting thing is I see GraphQL as the infrastructure that enables Relay more than I see Relay as a way of using GraphQL. And that might be, I think, I've been thinking about this recently quite a bit, and that might be what kind of helps clarify the distinction, because, for example, Apollo being, the elephant in the room is very similar on many levels. So it always, you have to figure out, why would I choose Relay other than, I want to scale to enormous sizes, or, you may not care about things like data masking. And I think it's mostly a philosophical thing. Like Relay matches, what I adopted GraphQL to solve, and it's the best for that job.
That's really interesting. Can you expand on like GraphQL being the technology that's meant to power Relay and not the opposite?
Yeah.
What's that different paradigm between like maybe things like Oracle and Relay or Apollo?
So it may end up being a distinction without a difference, if that's the saying. But I suppose what got me excited about GraphQL, because I've been using it a long time, the first time I saw it was, I think it was the start of 2015 when Facebook first showed it off to the world. But what they showed off was kind of a hybrid of GraphQL and Relay. It was like this thing where a component could declare what data it needed, and somehow magically that happened. And it was over the course of that year, that until the release of GraphQL in June, that we kind of realized there were two technologies at play here. There was Relay and there was GraphQL, and we weren't really sure where one started and the other, where that transition point was. So, and when GraphQL itself came out, I was like, oh, this is cool and all, but I want Relay. This is what I signed up for. This is the thing that fixes this getting component data into the component problem. So it's like, okay, now waiting for, I think it was October the same year, for Relay to come along. In the meantime, I was playing around, trying to essentially simulate the API I'd seen from the various talks, just doing some very bad hacky code. But essentially, I was just waiting for the opportunity to use GraphQL as I'd seen it, like the value. And so it's kind of that, it's very much the idea of like, I want to be able to, as closely as possible, just build components using the data I need. And, if it's possible to automatically get that into that state, I don't want to think about everything else. So the fact that GraphQL is there and is the way this is achieved, to me, is whilst not quite an implementation detail, because you do still see and interact with GraphQL, it's a foundational technology that lets you get to that endpoint. It's like, I use a database not because I want to use SQL. I use a database because I need a database.
Right. Yeah, that makes a lot of sense. And I'm trying to figure it out because we haven't talked much about the client side of things on the show yet, which is why I'm super happy to have you on today. Would you say, like, the way I see it is, like, if I look at, let's take for example an Apollo component, I often see people like still collocate a query with a component. Would you say the main difference is like Relay is focused really on fragments?
Yeah, I think from the code bases I've seen, and like, I guess to be fair on Apollo here, I've only seen open source code bases. Right. So I haven't seen like maybe sophisticated or production ready ones. But there seems to be a difference where Apollo code bases seem to be quite top down. Like, essentially, you have your entry point and you have a query, and if you're lucky, maybe they're making use of fragments, but more often than not, the query seems to be the main point of entry there. And I think with Relay, as much as possible, I'm trying to push the query to the boundaries of my thinking. Like, ultimately, there has to be a query to tie everything together at the end of the day, but mostly I'm just thinking about fragment composition. So it's a very bottom-up way of working.
Yeah, it is such a powerful thing, and I think it's kind of underused. You don't see fragments used in that way very much. So it is a big point.
Yeah, and obviously it is possible with Apollo. Like, there's nothing stopping someone making use of fragments quite heavily in an Apollo code base. There are some issues where without the static compilation, you kind of have to be importing the string from the component, wherever the fragment is defined, which loses you some of the, say, code splitting optimizations available to you. But I don't think that's a problem that can't be solved. Like, there's nothing stopping anyone introducing a build step that, ties all those things together.
Right.
So I mostly have experience on the server side of GraphQL, and that's an interesting point. I've kind of seen fragment use attempted in a big Apollo code base, like the one we're on right now, and I've seen fragments as a little bit of a foot gun, where you include it in one component and then it gets included in a different component because you want to reuse the query, but maybe the one component you just included in is requested in a completely different way, and it ends up like smashing some backend service for data that you didn't really even need for that component. Is the idea of Relay that it creates these fragments for you based on like what you need, like at a component level?
So you are explicitly declaring the fragments. So
okay.
I mean, there is a small tangent. There's a library, GQLS, which you may have come across, which attempts to essentially let you purely use the data without doing any of the actual declaration.
Okay.
I haven't tried it. I'm curious about it, but it does all this stuff at runtime, which to me creates some other issues that they may have solutions for, but I haven't looked into it heavily enough. So with Relay, you essentially, for every component, you may have one or more GraphQL fragments, the fragment being bound to a type. So if your component expects a user in a product, it will have two fragments. But if it expects a product that belongs to a user, it would just have one fragment, which is the one on the user, which includes the product data. But the key expectation is that you are only declaring the data you need for that component. So you don't prematurely say, oh, well, my child component needs this data, so I'll get it for it. You let the child component worry about that.
Mm-hmm.
And I found, so in my former job, we used Gatsby very briefly for the website. And even though Gatsby at that time did use Relay Compiler, it didn't impose any of the kind of the data masking workflow. So it was really just a build tool. And we found, going from like a mobile React Native app using Relay to using Gatsby, all of the mistakes that relay data masking purports to solve started happening. So it's like, even with the experience and knowledge and the team used to using relay, as soon as those rails are taken away, we lost that discipline.
Mm.
And that was kind of interesting, because it kind of told me that at the end of the day, it doesn't matter how well intentioned, and obviously the team had varying degrees of experience. At some point, people will take shortcuts if their tooling doesn't stop them.
Yeah.
Makes sense. You mentioned data masking a bunch of times. Can you explain what that concept is?
So this is the hardest part of relay to explain. So it's the idea is that essentially, when you get your data back from a query, that data essentially goes into the store. That data isn't then passed immediately down the component tree. And what gets passed down the component tree is essentially a reference to the fragment that the component wants. So the query itself at build time is made aware of essentially the downstream requirements in the component tree. And that basically means it's impossible for a component to access data from that query that it didn't explicitly ask for. So it kind of forces you down the guardrails, like you're bowling with like the bouncers up.
Right.
So
that makes sense.
And it can be frustrating, like, because you want to just take shortcuts, you want to get things done, but you kind of do start seeing the value over time.
Mm-hmm.
We've got a question in chat from Diana, SUV or SUV, or can we compare this approach, only component declaring data, to the dream query approach that Yelp engineering advocated for in our episode with Yelp, which Andrew, I'll let you answer. I don't know if you've heard of that dream query thing.
I'm not sure I know what it's being referred to, so you might have to remind me.
Right. So when we had Marc from Yelp, he mentioned an approach to use of like, for schema design, basically, or an API design, is they ask their front end teams to think about a dream query they would like to power their UI. And I think, I don't want to go into this yet, but this might be a great time. You wrote something about data modeling recently that seems very similar to this, to basically like taking a look at a UI and imagining what the best schema design would be.
So we're moving a little bit, I guess, away from the relay discussion to more about like, how would you design your schema? So it's kind of tricky, because ultimately, so the way I've used GraphQL and tend to advocate for being its strength is for first-party usage. So APIs where and trust the consumers. So you're building the API layer for a website and your own mobile apps. I think in that situation, it's essentially the client is a customer of the people building APIs. The people building APIs may also be the people working on the client. It may be a different team, but you kind of need to have that relationship. So you want to be building around a combination of current and anticipated future use cases. Obviously, you don't want to anticipate too far into the future, because you'll start solving problems you don't have. But an approach that I've basically taken is like, that you've got certain UIs, maybe they already exist and you're migrating to GraphQL, or you're in the early stages and you just have some wireframes, but you have some basic idea of what goes on some screens, what entities there are, and how they need to relate to each other. And that can feed into essentially what you need the API to be, or as close to as possible. Then you kind of mix that with the realities of the underlying database tables and the business logic and things like that, and you try and reach this happy medium where essentially you're providing an API that does everything the client needs, but doesn't conflict with the realities of how things work behind the scenes. And obviously that requires conversations, which some companies are not necessarily set up to the point where front end and back end talk very often. But I think if you do have those conversations going on, you can end up, with quite an intuitive, enjoyable API.
Yeah, I completely agree. I feel very scared of running a third-party API for exactly that reason. Like you don't know what people are exactly going to build, and you don't know if you're like painting yourself in a corner where it makes it very hard for someone to build something.
Yeah.
I actually see this kind of almost misconception because we run a third-party API. I see a lot of people saying even, "Oh, GraphQL is great for third-party APIs because it's so flexible," but internally it's less great. But I truly don't think that's the case.
I imagine
it can work as a third-party API, but I would definitely not say it's the sweet spot, right?
Yeah, because I guess in the case of the GitHub one, I imagine there's some processes in place to like limit the complexity of the queries, but ultimately the monitoring and logging and the usage requirements must be. You're definitely in this is not the fun way of running a GraphQL server territory.
Right, exactly. It's I mean, I wouldn't say not fun. It's fun, but it's definitely more complex than running a single client, single server scenario. With probably the simplest, which I'd argue is not the sweet spot either for GraphQL necessarily. But Andrew, I think you might.
Oh yes, my other controversial opinion.
We can go back to. I think to answer Diana, I think if we come back to Relay, I think having fragments or queries like co-located with components definitely does put you in that mindset of taking a little out of part of a UI and mapping it to a part of a schema.
But I think especially if you're also approaching things from, say, maybe the level above design systems on the front end, where you're kind of looking at like molecules or organisms of a bunch of components related to each other. Having a GraphQL fragment that essentially drives all the data for that component, and therefore that can tell you two things. It can tell you, inform the data model behind it, but it can also guarantee that whenever you render this component, it has the data it needs. You don't need to really write tests about the fact that this could be used in the scenarios of like 5 or 6 different queries, because that essentially your build process will fail if you try and use that component in a way where it's not going to be satisfied.
Yeah, that is truly beautiful.
Yeah, that sounds very nice. I wish we had that. There's so much. If you can put things in the build time rather than runtime, you avoid yourself a lot of pain. Is that the main?
You have to read the docs, though. That's the hard part.
Yeah. Who's got time for that, right? Is that the main difference between Relay and Apollo? Would you say, like at a high level?
So at a functional level, I think the fact that there is a mandatory build step, and so all the queries are static, and that combined with data masking is the biggest substantial difference. The philosophical one is that I think Apollo is obviously incentivized, and for good reason, to help GraphQL grow. They need the adoption barrier to be quite low. Having a mandatory build step does get in the way of that. So Apollo is always going to be geared towards essentially trying to get you to the point where you can render a component or something in React or any front-end library using GraphQL. They want to have that, I guess, feedback loop and success point to be as early as possible. Facebook doesn't have the same motivations. Essentially, they don't really gain that much from Relay becoming popular. It may help them with hiring and things like that, but they're not. They don't have the same goals. Their goal is to essentially support the needs of Facebook, which overlap fairly well with what other people need, but then it's not a perfect Venn diagram of two overlapping circles.
Yep.
Yeah, that makes total sense to me. Like, I think what you hear a lot, and I don't know if you hear it still, but I've heard a lot that basically like Relay is complex. Other clients are less complex and easier to start with. Is that still true today? Is like Relay an insanely complex like black box, or would you say that has changed?
So I haven't actually tried out the experimental stuff yet, so I can only really speak to, I guess, the the stable API, which is still based on high order components and render props for the actual query rendering itself. I think like for like, I mean, actually allowing for API differences between the hooks and the different approaches, I think the only real challenge is the fact that there are more moving parts to get running. In a sense, you need the relay compiler. But like, I don't find myself feeling like I'm having to do a lot of work. Actually, the one thing that's annoying is having to bring your own network layer. That is a frustration. And I do find myself essentially copying and pasting ones from other projects, which I would prefer if there was a sensible default.
Right. So by default, really doesn't care about how like as soon as it leaves the client, that's on you basically.
And I'm saying this from memory, so if someone in chat knows better, maybe they've introduced a sensible default by now. But as far as I'm aware, there isn't a standard network layer. So I think there is definitely still a hurdle in getting up and running, but that's kind of, you only face that hurdle the first time you try using it. Once you used it once, it's fairly plain sailing.
Yeah, that makes sense.
Coming back to the part where we may possibly disagree, Andy, on the third-party APIs. So I wrote this thing, I forget why, how, and when, but I wrote this thing called like the GraphQL sweet spot, and I basically said the GraphQL sweet spot is like when you have multiple internal known clients. That's kind of a GraphQL sweet spot, and public API works, but it's just not necessarily the sweet spot, and single client, single server, not necessarily the sweet spot. What are your thoughts on that?
So I think we're broadly in agreement. I think I'm fairly definitely a minority on this point. I think you can still justify GraphQL even if you only have one client. To me, and I think this comes from the background of being interested in solving the problem that Relay solves rather than the problem that GraphQL solves. The development experience of working with Relay does not require you have multiple clients. You get that experience even if you're just building an app or just building a website. Now, so that kind of tells me, but you don't actually need GraphQL there. You could have something else that presents a GraphQL API to Relay in kind of the same sort of shape, but whatever it ends up being is going to look quite like GraphQL. So I think that's kind of...
Yeah, so you see it from the client's perspective, and
yeah,
it does make sense even for a third-party API if you think about it. If you want to offer clients the possibility of using something like Relay, then you got to start thinking about exposing.
Although, and there's the handful of things you have to do to make things Relay compatible. But again, it's not as bad as everyone's led to believe.
Right, because I think that might be maybe a thing of the past. Like when we first built our schema, it wasn't really modern yet. It was the first, I think, Relay Classic was called. And there's a bunch of restrictions, right? The input and payload types, the client mutation ID.
So the one hard restriction which is still there, which there is experimental support for releasing it, is the one where if you have a field called ID, it has to be globally unique.
Yeah.
There isn't now an experimental API for essentially providing your own mechanism to generate the cache ID for a type, but because it basically puts a lot of burden in the client code, I would still say that you're better off adopting the original pattern because it's just going to make your life easier. And I think that's generally true of all Relay things. Is even though they're increasingly non-mandatory, they're still good ideas.
Yeah, I think if there's any design top tip, it's to give things their own unique ID, and even better, just make them universally unique. Like don't use incrementing integers as IDs. Just make them opaque, unique strings, and you'll thank yourself for it.
Yeah, obviously Relay. GraphQL itself tries to enforce that by having an ID type, trying to encourage you not to use an int or a string type. But Relay goes a step further, well, the relay tooling does. So GraphQL relay JS, generates the IDs based. Essentially, it concatenates the type name and the ID, and then basically for encodes it. Which, to be honest, is such a trivial operation that I think that is the easiest of all relay patterns to stick in your schema.
Mm-hmm.
But the main reason is just to really communicate to clients, don't mess with the IDs. You're supposed to just pass them around as is. Don't try and do any guesswork.
What do you think about, do you give every single object in your schemas IDs? Because that's one thing I've seen a lot of people think about. And I've thought about this a lot too. Like for objects that don't exist without a parent, do you still give them an ID?
Yeah, so I think this comes down to again, considering your use case and maybe related to the original schema design question. If it doesn't make sense to access it outside of the context of a parent, like let's say you have a social network and two people could be friends with each other. So you've got a user-to-user relationship.
Mm-hmm.
That now in the database, that is probably represented as its own join table, and it may even have its own ID. Like if you're doing it with Django, it would. If you're doing it with other backends, it may not. But it may also have metadata, so you may want to know the date this was happened, or any other number of things about this relationship. But until there's a point at which any of this metadata is relevant to the client, there's no real need to think of this thing as its own entity. It's additional context about the thing in the parent. So you it's relatively ephemeral, or actually ephemeral is the wrong word. Ephemeral is more about, I think, the connection side, which we can get to. But I think there's no reason to prematurely add ID to these kind of relationship things, because you can add it later relatively easily. And I think you don't want to create more work for yourself up front, really.
Yeah, that's good advice for sure. You met
the connection side is the interesting one, because that's essentially a data structure for managing pagination,
Mm-hmm.
and that data is only relevant in the context of the parameters you provide to the pagination. So things like the cursors. My favorite example would be if you're doing a search based on distance from a certain point, and you want to add a distance from field essentially to each result, that doesn't belong in the actual entity you're returning. That's metadata about the context of the query itself. So that, for each thing saying this is 5 kilometers, this is 3 kilometers, so on, that is only relevant within the context. So it doesn't make sense to cache that as its own data.
Yeah, that's so true. And I think connections are such kind of an underrated concept. I feel like everybody's using them, but everybody's kind of complaining about the verbosity of edges and Node. But there are some problems, like the one you just mentioned, that are just not really solvable without some kind of pagination container.
Yeah. And I guess the question is, because you can not have the edges concept, you can just say, well, now we realize we need metadata, let's just wrap the type we're paginating over and do it that way. Yeah. But I think there's arguably some value in having a consistent shape for what pagination looks like, so that it works the same everywhere.
Yeah, it's actually quite beautiful that it's been adopted so broadly. Like the fact you can go from one GraphQL API to another, and you've got consistent pagination experience, not only within an API, but between a bunch of APIs, between different companies, is actually pretty great.
And I enjoy, though haven't used the GitHub's optimization of giving you direct access to the nodes as well, because I think that does help address some of the reservations people have about how awkward it can be in the client to actually traverse 3 levels deep of objects just to get the thing you care about.
Right, definitely. Sometimes a client might just really not care about the edges at all. So that does help for sure. So to me, I think we've talked about this before, Andy, but there's two sides of the connection pattern. There's the fact that there's like the containers, like the connection object, the edge object, and also the cursor based approach to pagination. And I feel
Yeah,
like they can be separated. Do you think every app can
yeah,
use
and this
cursor based
is,
pagination?
I think, so. Unless there's some DBA in the chat who's going to correct me about this, I'm fairly sure cursor-based pagination still remains the most efficient way to paginate over large collections. So I think in that sense, if your goal is performance, you can't, trying to fight cursor-based paginations is fairly futile, but it does create different UX expectations. You can get around some of them by having a total count field, but that, depending on your database, will introduce its own costs. But if you can't do that, then you can't do a standard like random access pagination where a user can click to a specific page in your results. And that is a decision that it's not just an engineering one, that needs to involve, product and UX, like, are we willing to make this trade-off? And this is why I tend to prefer splitting up the discussion about connections, because I think people to kind of throw it out the baby with the bathwater and say, oh, well, I don't need cursor-based pagination, so I don't need any of this structure. Whereas most of the structure is still applicable even if you do limit offsets. It's only some of the details that change.
Yeah.
We definitely have had services in our API where we did want to give the appearance externally of the cursor-based pagination, but really it's just like a base 64 encoded offset limit or something. Is that the approach you're talking about, or is there like a way to use offset limit within?
So I'm aware of, and I have seen, so maybe it's the one you're referring to. I've seen essentially people implement that approach within, I guess, the cursor-based pagination shape.
Mm-hmm.
I haven't tried it. I assume it works. My only reservation there is perhaps confusing the client because perhaps it is relevant to communicate which strategy is in play.
Mm-hmm.
Like, if you are going to support both, maybe there should actually be separate shapes, separate containers. But I'm fairly on the fence about that. I've always been lucky enough that I've worked with UIs where I can get away with cursor-based pagination, or I've always won the fight to do it. But I think if I was building like a new commerce site, there's kind of an expectation, even if it's not a particularly useful one, that you can just go to like page 5 of your search results. I say not useful because I think if you are going to page 5 of search results, it probably means you're filtering them. So we just had an audio issue, but I think we're okay.
Yeah.
Awesome. So yeah, I think the arguments against using cursor-based pagination, even from a UX perspective, aren't particularly strong ones, because there's normally a better way to solve the same problem.
Mm-hmm.
But you do actually have to come up with those alternative solutions. And again, that becomes a full team decision, not just an engineering one.
Right.
Yeah, I've never seen it, but I could totally see like in a mirror image of pagination, like of connections, but using limit of set instead. Like, you have edges, you have nodes, you have connections, but they just have different arguments.
So I think I had a blog post. I don't know if it's one of my several, but there is another one, demystifying GraphQL connections, which I do kind of have a bit of a straw man approach to limit offset near the end, I think. And I think it does end up being fairly similar. I never actually implemented it, so it's pretty much just a sketch, but I think that's kind of what you're talking about there.
Yeah,
exactly. Yeah, let me post in the chat. Yeah, I forgot you finally wrote this one. It's a great one.
Yeah, this is a great post. I feel like this is what a lot of people get hung up on, is just this this pattern is something they haven't seen, or it seems like very strange.
And I definitely agree with the kind of the resistance to adopting something if you don't really understand what problems it's solving. And I'm going to be a bit harsh on Facebook here because I've tried to essentially raise the point that perhaps the concept should be split up even when documenting and discussing these things, because I do think there's a bit of like FUD around this thing that you don't really need this thing is too complex and so on. And I think people don't really understand the two problems being solved with one solution.
There's definitely a bit of confusion around like the fact that this was part of the relay specification at first. So it's not a GraphQL thing, but some people think it is like natively a GraphQL thing. Now it's more of like a best practice.
And then also that, and you don't even need to use it with relay anyway, because there's nothing like relay has some optimizations for them, but that's it.
Yeah, so it's at this point it's kind of a good practice, I guess, that a lot of people use, and it is one totally.
Yeah, we mentioned on I guess the other relayisms in schema design. So we've covered obviously connections and the unique ID. There's the node interface, which I think is again one of the things which is a bit of a pain to do, but worth it because it allows you a general pattern of essentially refetching in relay terms, but going back and doing follow-up queries from a certain entity within your graph. So it gives you a common entry point, which is really valuable. Then I guess the input, the format of mutations, it used to have this client mutation ID. That didn't actually go away, technically speaking, with relay modeling, because there was a bug which in the client which prevented the store updating correctly without it. But now you definitely don't need it. But the actual, I guess, the input payload and the output payload shapes are one of the things where I would advocate them in general, because I think you agree on this as well. But being able to provide just a single input argument to your mutation means you're changing the mutation arguments over time becomes a lot more straightforward.
Absolutely.
And similarly with payloads, I guess the payloads is the more, I guess perhaps the more relay of the two, because so with relay, essentially the model of mutations is that you're supposed to return essentially references to anything in the entire graph which may have changed as a consequence of that mutation. It's more common outside of relay to say a mutation to add or edit a book just returns the book, whereas in relay you would have like a payload type around that, which it would contain the book itself. But say you had you had an author type and the author has a numbooks field, a denormalized count, you would want that counter to change as well. So you would return the author so that the client can update both those things. The idea being that you don't have to do any follow-up queries to get the store in a consistent state after doing a mutation. It's not always possible, especially when like pagination is involved, but for the vast majority of mutations, you can essentially get consistent store in one go.
That's a good point. One weird question I'm curious on you guys' thoughts is like a lot of people have asked me like if we do, I've always said input and payload types are great. Can we apply that to the query side of things as well? So like fields that have arguments, somehow like I don't give them input types and I don't wrap every return type in a wrapper type either. And I think that's fine, but it's hard to say why,
Yeah, I think I'm the same thing. It's like it feels like a different thing.
Yeah.
I think like for a lot of, I guess, the fields, you're dealing with single arguments. So like, if you have like getting I always use books example, but you're getting something by, ISBN or ID or something, I would probably have a book by ISBN field on the query type, and that takes a single parameter. So I think in those cases, it's like, I don't know if you're familiar with Python, but it's kind of similar to my rationale about when to use positional arguments versus keyword arguments, where if it's a small number of arguments where the ordering feels obvious, I would go with positional. I think when it gets more complicated, then I would essentially start creating structures. So I think for a search or filtering API, I would, if I was doing it building on top of a connection, I would have the relay connection arguments as they are, but I would have essentially a filter input type as an additional argument there, and kind of build whatever crazy filtering structure I need.
Yeah,
but yeah, it's difficult because, like you said, it's hard to, I guess, quantify why it should be different to mutations, even though it feels like it should.
I completely agree, and have the same kind of rule of thumb, which feels bad. It feels bad to say, like, this is a feeling I have about how to do something.
I'm hoping at some point in the next few years I'll have a good reason for it, but for now, let's go with my gut.
It might be interesting to try doing just those input types for everything. And then as far as payload types on queries, I've seen something like maybe if you want to return like an error or something's in a different state, like you can return some kind of wrapper there if it's important for your.
So I've definitely done that with mutations. I think this is the big error conversation in GraphQL, but I've gone down the routes of using union payload types for mutations, so that it's a union of either a success value or any number of error scenarios.
Mm-hmm.
That works quite well. I haven't adopted that for querying, but I have thought about using it perhaps if I wanted to be really explicit about things like authorization checks. So maybe if there's a reason why you couldn't get this product or something, it's the reason that you're not authorized, then maybe that field returns a union of some generic unauthorized type and product. Gets a bit awkward when you're dealing with scalars, but it kind of works quite well for object types.
That's true. Mm-hmm. That's a good point about scalars. If you decide to go with that approach on a query type, it seems like you got to go all in and like have other types around scalars as well, and like it seems like a lot, but I can see it being really nice as well. Like embracing like the I don't know if you've used Rust, but like really embracing like result types and like dealing with user errors like directly within your types.
Yeah, not with Rust, but I dabbled with Elixir, and I do enjoy just seeing errors as essentially part of the system itself rather than something exceptional. Right. I think there's probably a distinction, and it's probably when you want to crash or not. I think, and part of this may come down to the way you're using GraphQL. Like again, this may be a relayism, but I try to build my entire UI for a given screen with just one query if possible, which means if we're dealing with scenarios where certain aspects of the UI are made visible or not based on who you are, your roles and your permissions, it's expected that some of those checks will fail for any given query. So you don't really want to be throwing exceptions in those scenarios, because then you're basically going to be throwing exceptions for every single GraphQL query.
Right.
So it's better to model those explicitly into the schema itself.
Yeah, that's true. Like the wrapper type thing, I'm a huge fan of. One thing I don't see mentioned often that annoys me a lot is how it plays with graphical and documentation. Like when I'm trying to use a mutation with graphical, like it just tells you input, and then you click on the input type to see what's in it, but you lose all context of what the mutation was. It's a small thing, but it's just like there's a lot of indirection to find out what you need.
It's also interesting as how as a tool it's changed so little over the last 5 years. It's basically, I mean, there have been changes and improvements, enhancements, but essentially the basic interface is still as it was.
Yeah.
People have built a lot of things on top of it. Apollo have definitely got some impressive stuff with, I think it's Explorer. But yeah, I think when I see people saying, "Oh, you don't need documentation, you've got graphical," I'm like,
yeah,
I would actually prefer a page on a website, to be honest.
Exactly. I agree, though. The Apollo, Explorer Studio, or their new thing looks incredible. It does a lot of amazing things, so that's going to help for sure. Yeah, it's
I've still got some skepticism about the performance tracing side of things. I think I've spoken to you about this before, but don't know. Do we want to go into that? I don't want this to become too much of a kind of be hard on the follow session.
I'm actually, maybe we don't have to harp on it, but like I'm actually interested in this space generally, like how like observability into your graphs out of performance. Like when a client takes a dependency on a field, what will the impact be to the user experience? If you can provide
that is definitely it's useful to know. I guess my skepticism is that I found, and maybe I'm just missing something completely here, but the more optimized my GraphQL server gets in terms of whether using data loader or more advanced things, the actual execution of where the data loading happens becomes divorced from where the field resolution happens.
Yeah.
So, you may look ahead and actually start off a fetch early so that by the time you actually resolve it, it's essentially free because it takes 0 time.
Right.
But that's not a meaningful assessment of the cost of that field. So I guess communicating the end user benefits, as long as the numbers you get out are meaningful, does definitely have value. But in terms of helping you optimize your GraphQL server, actually having traditional observability tracing around the I/O itself, to me, seems more valuable.
Yeah. This is something that we're trying to get a grip on too, because it's like if you support like a batch of operations in a single HTTP request, you could maybe data load something. Say you share your data loader across all operations in a batch. Maybe one batch loads the data and the others benefit from that, and it's really hard to communicate that, I think, or it could be confusing to see results where, in one case, it's really costly, and then it's free in the other ones.
Yeah, and you might have situations where in some queries, accessing this field allows you to just use a standard, where clause where the ID is this, which is marginally more faster, more optimal than using an in query. And so it kind of depends on the outer context of how a field is being resolved as to its ultimate performance. So if, you may have like most of the time it's really, really fast, and sometimes it's really slow, and that may have nothing to do with that field itself. It may just be the context of the parent query.
That is so true. I agree absolutely 100%. I've kind of like surrendered to the fact getting per resolver metrics ever being useful because of these reasons. Like it seems like a resolver's time can be influenced by like the field logic itself. The ordering of fields, Tony, that was a great example. Like other queries you're running as a batch with, the current state of your system, the arguments, and then that context argument that can contain like anything. So it's very hard.
But then it may be that just having that aggregate view of the overall, scenario and performance of that field is still valuable. But I think, it's of more value to the client consumers to have some expectation of costs rather than some real life, this is actually what it really costs.
Right. Because it is, Tony, as you were saying, it is a valid concern. Like as both a server team and a front end team, you want to know like what impact is this new query going to have? And that's very hard to tell.
Yeah.
Have you been dealing with that?
Who's that for? Yeah.
I was asking Tony, did you figure out anything like without having like super precise monitoring? Is there like a kind of like organizational thing or process thing you can do? Or
I think we have fairly decent without doing tracing. We have we log errors. Every error gets logged, and then we have basic metrics, timers, and counters on fields. And you can kind of put 2 and 2 together, but it's a manual process. And it's not extremely visible to client developers. So where tracing seems like it may provide some value if we can get the messaging of it correct, like this is why this happened, and it's a lot of data to collect, and when you resolve a lot of fields, it can be expensive to collect. But I don't know. I'm kind of on the fence of like, is it worth doing? It's like certainly can be doable. I don't know. It kind of the point Andy raises. I'm not sure how valuable. I think there's some value there.
Yeah.
It's tricky.
I guess we've all worked at different scales. I think perhaps I've generally experienced the smaller end of the scale, like the highest traffic GraphQL server I've worked on was accidentally dealing with a few thousand requests a minute. I imagine most you two dealing with orders of magnitude bigger than that. But what I did find was that for first party use especially, when building realistic UIs, it was really hard to build or come up with a scenario with a genuinely bad query. Like, you rarely went more than 3 or 4 entities deep relationship wide. So most of it was, the query was wide if you were rendering a lot of, things like navbar content or, general header, site header and footer. I had I think the blog post you mentioned at the start, the one about GraphQL request waterfalls, that has an example which to me was the worst case realistic app UI query I could come up with.
Mm-hmm.
And I think that had 2 levels deeps of entities and another 2 level deeps of connections. And even in that kind of scenario, without caching, like when I was working on a similar kinds of UI, we're still getting overall response times of 100 milliseconds without any caching whatsoever. So you can get a really long way just by using basic data loader strategies, and that may mean you don't really need to worry too much as a client developer about the overall performance of what you're doing.
Yeah, definitely. I think that makes sense. In fact, Diana in chat is asking, so what are useful metrics then for monitoring? Because we kind of said that the per field was really hard to do.
Yeah.
So what are your thoughts on if you're starting a GraphQL server?
So I would definitely use an observability tool. There's debate about what observability means, but you can definitely do tracing, like using an APM. So anything from Datadog, even Amazon X-Ray, to Honeycomb and so on. I think Sentry supports monitoring now. So definitely get an APM. And then the first thing you want to do is add a trace around every GraphQL query itself. And you kind of want to annotate that with the query name, which your client would be providing. Send the variables as data, obviously sanitizing anything that's sensitive. Then just sticking spans around every I operation, be it a call to another service or a database query or something like that. And that will give you a lot of answers about the overall performance, because that's where most of your time will be spent. You may have some CPU intensive resolvers if you're doing things like markdown parsing, or in my case, I was doing essentially tweet formatting style parsing to tokenize things like that. But they're going to be unusual cases, and they're still going to be fairly fast. Like IO is going to be the big one.
Yeah. I'd say for us, we were at the scale where tracing was kind of failing because we were doing so much of it, and it was producing either so much data or causing so much CPU utilization that it would slow down the rest of the API. So yeah.
I haven't experienced that, but then I guess I'm fairly new to the tracing world. What I would say is, if you haven't looked at Honeycomb as opposed to the others, maybe give it a try, because they advocate for a sampling-based approach, which essentially you send less data to them and you get the value essentially from holistic analysis rather than diving into a particular one.
Yeah. Yeah. The one thing when we did experiment tracing that I found, top of my wish list, was to be able to sample the traces that I cared about. Because if you're running something at a good level, like you're 99.9% available and your 99th percentile latency is really fast, you don't care about the vast majority of traces. You want to know what's slow and what's broken. And this may have changed the last time we looked, but it was really hard to dig through all the traces to find those like exemplars of what's slow and what needs attention.
Yeah. So I guess with the open tracing standard, there are some fairly standard ways of annotating a span to indicate that this one has an error in it, things like that. So I think that might help improve the visibility of things actually going wrong. I think in terms of general understanding of performance, I think that's where sampling comes in.
Yeah. The trick is it's sometimes you need to sample before the request goes in. Otherwise, you fire off all your traces and they've already been ingested, and then they have to be rejected at some point if you decide not to sample it. So, like, say if I sample at 1% of requests, but only 0.1% of requests error or are slow, it's very hard to find that 0.1% of requests before you know the result.
Yeah, we're definitely, I guess, reaching the limits of my understanding of, say, honeycomb's magic. But okay. I would say definitely if you are, like, without being too much of an advocate, just because I follow most of their team on Twitter, but nice. They seem to know their stuff and they seem to talk about these kind of problems quite a lot. So I think just take a look, see what they have to say.
Yeah, honeycomb looks super interesting. We haven't dug that far in. But what I wanted to say is lacking tracing, I think you can get pretty far measuring with metrics, which are just like counters and timers, which are relatively cheap, as far as I know, relative to tracing. Around request, I don't know if you guys have ever heard this, requests, errors, durations, like the red monitoring. So like,
I haven't heard it phrased like that, but I think you can explain it, but I think I know what you mean.
Yeah. So how many times is a given thing requested? How many times is an error? And from that, you can calculate like success ratio or like error-free rate, right. Or there's different ways to skin it. But and then durations. So those things will tell you statistically, like you can aggregate counts, you can aggregate distributions of latencies, and it'll tell you like what's slow and what's erroring fairly cheaply. But it doesn't tell you like, oh, this came from this query from this client.
Yeah. One thing that's
and I guess
go ahead, Andy.
Carry on. Sorry, I was just gonna I guess add an aside there. I think one of the frustrations that many, I guess, traditionalists in terms of REST have is that your request logs don't give you enough information about what's going on in your GraphQL server. And I definitely, I guess, sympathize with that. But at the same time, it's not hard to add the logging yourself. So.
Yeah, right. That's true. It's true. Out of the box, it definitely maybe doesn't give you as much, or at least it's a bit more complex than if you were setting up REST. But yeah, it's possible to add logging for sure. I think one of the monitoring problem I see for the third-party side of things is, let's say you do have like your success rate. It's very possible for one client at some point to make queries that start timing out. And it's not necessarily an issue with the system. It's because the client is simply requesting for too much data. And again, if you're serving internal clients, you can kind of detect like, hey, like you walk down somebody's office and said, can you stop doing that? The third-party API, anybody can do that at some point. And so what we found is that timeouts don't really become an exception anymore with GraphQL. It's just like almost like part of your logic where like, hey, GraphQL queries can run for X amount of time, after which they'll be stopped. And it doesn't make sense to have like an SLO or SLAs for that.
Yeah. Kind of like when asking for something that doesn't exist, it's not really an error. Like there's the concept of null for that.
Right.
Similar to that.
Definitely.
Yeah, and I guess that's similar to the error union modeling is deciding whether it's worth going crazy with the modeling to account for these expected scenarios, because I think, yeah, even in a microservice architecture, even things like network failures become expected, and you may want the UI to expose some kind of retry behavior for just that subset of the query. So yeah, I think it very much depends on your own use cases, but yeah, you can go overboard or the opposite with like modeling the world.
Yeah, this is such a this is such a rabbit hole, the errors in GraphQL, because like if you think like a 404, for example, for certain client applications, that's an exception. Like I should not have tried to load something that doesn't exist. For in other type of client application where it's like some admin where you literally input an ID, the 404 is like a user error, and it's very hard to design your schema
To be
that
honest,
way.
I think for that kind of thing, it could be determined at the query level. Like if I'm building a page on a website where the product that I'm accessing doesn't exist, like the query may return null, but I can decide at the page level what that null means. I don't need the GraphQL server. It's more, I suppose, whether it's worth doing the additional modeling when you do need to know the difference between it's not found versus I'm not allowed to see it. Because I guess the authorization is an example where you may choose to display the reason why you can't see something, like you don't have permission. But in some cases, you may not want to expose to the clients that is the reason. So it really, maybe it's not helpful that you can't just have a one-size-fits-all approach to how to deal with these things. But yeah. I think it's very much, you have to solve it for your own use cases.
100%. We're already at the top of the hour. So, Andy, is there anything you want to plug before we go?
Sadly not. I wish I did.
I have some things to plug.
I'm going to say Black Lives Matter.
Yeah, that sounds good.
But other than that, I have nothing to sell.
I'm going to say people should visit your blog because it's full of amazing articles. And generally follow Andy on Twitter because I definitely enjoy these hot takes.
Hot takes.
Occasional rants, most of them grumpy.
Yep. Let me post your Twitter in chat. Yeah, that's it. Tony, anything in mind?
Oh, let's see. Nope, just really enjoyed the conversation. I think I'm going to have to refer to some of these newer blog posts. I hadn't seen the one about demystifying GraphQL connections, but I'm definitely going to share that one with my team.
Awesome.
That's one of like the biggest sticking points for people that are just learning GraphQL and getting into the kind of ecosystem that I've noticed. So very helpful. Thank you.
All right. Thank you so much again, Andy.
I'm glad to help. Thanks for having me here.
Thank you so much. Thanks for watching, everyone, and we'll see you next week. See you later.